Hello students, this video is to help you review for the Unit 4 quiz that is happening very soon. It is a summary of all the different problem sets in Unit 4 so far from Lesson 1 to Lesson 5. Hopefully you've done these problem sets for homework. This is just a quick review of the answers to those. Every so often you should pause the video to make sure that you've done the problems, and if you haven't done so, try them, and then unpause them, and I'll show you how to do them. All right, let's take a look at the first problem set from the first lesson. In Lesson 1, you should identify the first problem in the problem set, which transformation is being shown in each figure below, and here are the correct answers. This one is a rotation. It looks like a reflection, but it's a rotation because part B, this is point B, has been rotated around to become B prime. C has been rotated around to become C prime. If this were a reflection, point C would have gone over here to C prime, but it didn't. It went around. Point C went around like this, so it is in fact a rotation. The orientation has not changed, only the direction of the triangles. This one's pointing to the left, this one's pointing to the right. For letter B, we know it's a translation. It's a translation because of these. We call these vectors. It's a direction and a distance. It's how far the shape has been slid. Remember, translation as SL, SL for slide, SL for translation. For choice C, or sorry, for number or letter C, yikes, this is a rotation. We know that we are rotating this shape so that instead of pointing upwards, R isn't pointing upwards anymore, it's now pointing downwards. If we want it to be more specific, this is a rotation of 180 degrees, either clockwise or counterclockwise. Doesn't really matter because it's 180 degrees, but remember in class we always talk about rotations in terms of counterclockwise. So that was question number 1. Pause the video before you take a look at the answers for numbers 2 through 5. All right, hopefully that was enough time. Take a look at the next couple of questions. Questions 2 and 3 deal with identifying transformations. In this case, we know this transformation is rotation, and it's rotation because we've changed our direction. X was pointing to the right here, and now it's pointing downwards, so it's definitely a rotation. Dilation would mean it's changing sizes. Reflection would mean it's flipping around, changing its orientation. And translation would mean that it's sliding but not twisting at all. Miss Russell, who's our intrepid art teacher, she's drawing reflected images in her class. She wants her students to draw reflections in a line. This first one is an example of a T, translation, because it is a slide. You can see all of these vectors indicating a slide, which is translation. For choice 2, it got bigger. That is an example of a dilation. That's where we put this D here. Dilation is not something that we've calculated in class, but we certainly spoke about the fact that dilations make shapes either bigger or smaller. Choice 3 is the correct answer because this line is the line of reflection, as evidenced by this R. And you can see that point B is closer to that line of reflection and remains that way, and point C is farther away and remains that way. For number 4, this line is kind of there for no reason because this is not a reflection as it looks like. This is actually a translation. We went from C to C prime, from B to B prime. You can actually take this vector and show that we've extended point C to point C prime, and that same exact vector is being used to change A to A prime, change B to B prime. So using that vector, we can easily see that it's a translation. All right, take a look at numbers 4 and 5, pause the video, and then I will show you the answers. All right, here's 4 and 5. This diagram represents a reflection, and we know it's a reflection because B and E are the same distance away from y is equal to x, and A and D are the same distance away from y is equal to x. It is an example of a reflection because that's the definition of a reflection. It's the same distance away from one central line, one line of reflection. In this case, it's y is equal to x. We know it's not a rotation because it hasn't rotated around the origin. We know it's not a translation because it changed its slope, right? The slope is different from D to E than from A to B. And it's not a dilation because the lines are exactly the same length. For number 5, we know it's a rotation. Take a look at point A. Point A has rotated from here to here in a clockwise direction. You could also represent it, if you would like, as rotating in a counterclockwise direction. A went all the way around 270 degrees in order to get from here to here. So it's definitely a rotation, not any of these others. All right, pause the video now, and hopefully you'll be able to try lesson number 2's problem set. Problem set from lesson 2, let's go. For number 1 and 2, a point is reflected over the x-axis. Here's the the way that you represent a reflection across the x-axis. We're looking for the point's image. You should remember a reflection over the x-axis is where the y value changes, which means 3, 5 becomes 3, negative 5. P prime is the image of P after reflection across a line y is equal to x. We know that both values swap when it's y equals x. That's one of our rules. You must memorize these rules for the quiz. They will not be given to you. So we know that negative 3 comma 6 becomes 6 comma negative 3. All right, pause the video until you do questions 3 and 4. Here they are. 2 comma 2 is reflected over the y-axis. A reflection over the y-axis means we're changing the x value. So 2, 2 becomes negative 2, 2. In this case, negative 4, 0 is reflected across the line y equals negative x. Here's another rule that you have to remember. Y equals negative x reflection means both values swap and they change their sign. So instead of negative 4, 0, it's going to be 0 and then positive 4. So that's choice 2. Hopefully you've done these next couple of questions. If not, pause the video. All right, here we go. If you take a look at this number 5, it asks us to find out the coordinates of vertex y prime. We know that y is here and that those coordinates are 1 comma 3. It tells us to reflect over y equals x, and we just said that a reflection across the line y equals x means we switch the coordinates. So instead of 1 comma 3, it becomes 3 comma 1. This is how you write it out if you were asked to write it out, let's say on a quiz or a test or something like that. This is how you write out a reflection across the line y is equal to x. And for number 6, it tells us that we're reflected across the vertical line x is equal to 3, which we drew in here. What are the new coordinates for z? You know that z is 5 units away from this line of reflection. So we figured out that z prime was 5 units to the right of that line of reflection. We counted it out. We know that it's the same y value, so the y value is going to be 2. It's the same distance above that y-axis. And 5 away from 3 is going to be 8. So here we go. Take a look at the next page. Question number 8, if the trapezoid is reflected across the dashed line, we did the same thing that we did for the previous problem. Its D is 6 away from that line of reflection. So its image, D prime, is going to be 6 away from that line of reflection. We figured it out very easily by figuring out the distances between. 15 comma 2 becomes 15 comma 2 plus 6 plus 6, which is 14. For number 9, it asks you to construct the line of reflection. It really should have said sketch the line of reflection. It's a line that splits the figures in half so that each figure is equidistant from that line. You could have drawn something like this. The Regents doesn't ask you to construct a line of reflection. It just asks you to draw them or sketch them, so you should be good to go like this. For question number 10, it tells you the triangle's vertices, and then it asks you to graph it, which we did in green here. Then it tells you that we reflected this triangle across the line y is equal to x. We drew the line y is equal to x in black here, and A prime, B prime, C prime is this red triangle. That red triangle has a couple of features, namely A prime, B prime, and C prime are all of these coordinates. Notice that negative 1 comma 1 becomes 1 negative 1, we switched. 1 3 becomes 3 1, we switched. And 4 1 becomes 1 4, you guessed it, we switched. Moving right along to problem set for lesson 3. If the letter P is rotated 180 degrees, what is the resulting figure? Well, we could take this figure and easily rotate it 180 degrees by turning it upside down, right? This part and this part can all be rotated around. Oh boy, that didn't work so well. But you know that this P part is supposed to be down here. That should look just like that. And notice that we rotated in a counterclockwise way. We're always going to rotate counterclockwise unless it says otherwise. Here we have the same thing. We have a spinner that we're rotating in a counterclockwise rotation, 270. So this is 90, 180, 270. You could easily have done that by looking at your own piece of paper and rotating it. In any event, it's choice 3. We know here it's a rotation of 90 degrees. It tells us that. It asks us to state the coordinates and graph the transformation. A rotation of 90 degrees means you take the y value, change its sign, and bring it to the front. You take the x value, you keep the sign the same, and put it to the back. That is just one of the rules that you have to remember. It is going to be asked on this quiz, so remember the rules. The image of 6, 5 under a counterclockwise rotation of 270, well, here's the counterclockwise rotation, and we know that counterclockwise rotation is another one of those rules. Notice that the x value turns into itself, but negative as a y value, and that y value stays the same. So that's 5, -6. Notice that we've also taken it from the first quadrant and gone to the second, third, fourth quadrant. You should remember the names of the quadrants for the quiz tomorrow. The image of the point 2, -3 under a clockwise rotation of 90 degrees, they sneakily tried to call it 90 degrees, but they had to say are -90. And you should remember that a rotation of 90, that's this green arrow, about the origin clockwise, so that's really -90, is the same as a rotation counterclockwise of 270. So we followed the rule, which was x comma y is equal to y comma -x, and then we applied the rule. We took the y value, brought it to the front, so that -3 comes to the front, and we took the x value, which is 2, and put it to the back and made it negative. All right, onwards and upwards. You can take a look at question number 6 and 7. Both of these are triangles that we've done rotations for. This is a rotation of 90 about the origin. Keep in mind 90 counterclockwise. And then a rotation of 180 degrees around the origin. Keep in mind that it doesn't matter which way you rotate 180. If you rotate it counterclockwise or if you rotate it clockwise, it's going to give you the same thing. We just followed the rules here, so hopefully you memorize those rules for figuring out the ordered pairs. For question number 8, I gave you a little procedure. This is not something that you're going to have to do, but you can pause the video, take a look at my step-by-step process. Again, this is not something that you're going to be asked to do on the Regents, but it's just something interesting that I thought that you might like. All right, onward. On lesson 4, there were a lot of different problems that asked you to translate because lesson 4 was the translation lesson. This t4, 0 is a vector, which means we're sliding things so that it loses 4 in its x values and it gains nothing in its y values. So we've slid all of these points, m, I, and l. They should be slid back -4. So this and this and this should not be there. If it's -4, 0, we're sliding it not there, but 1, 2, 3, 4 back here. So now we know that h and l correspond. So that h should be back here. The y is the same as the m, or it's the image of the m. So the m goes here, and then the a is the image of I. A and I correspond, so that should be back here. You can see that it's slid, but it hasn't turned. It hasn't lost its orientation, hasn't lost any direction. It's just slid. Here we were asked to draw a vector for each translation and state the rule. These are the rules. You could have also written these translations as vector notation. Pause the video and see if you can write it, and then I'll show you the correct answer. All right, here's your vector notation. Remember these kooky little arrows at the sides mean it's a vector. X changes by 5 and y changes by -2. X changes by -5, y changes by -2. For number 3, all I had to do every single time was just apply the rule. I subtracted 2 from the x value and I subtracted 2 from the y. Or I added 1 to the x and I added 4 to the y. It really is that simple. We've been given this vector notation and it says to subtract 2 from the x, subtract 2 from the y, add 1 to the x, add 4 to the y. Very, very straightforward, very, very simple. You can do this. All right, moving on to the second to last page here. Take a look at what we've done here. We tried to identify what the translation was. We know it's the change of x and y, and in this case, my x value went from 2 to 3. That's a +1. And then from 4 to 1, that's what happened to the y. That's a -3. So we figured out that the translation was 1, -3, and we applied that translation here. For question number 5, that was a multiple choice question that asked us, well, what were the coordinates of the image of point -3, -5? Here's the translation, and we applied that translation using the rule. For number 6, here were the appropriate translations. This one, 0, 5 means we just slide everything up by 5. And 2, 5 means we slide everything up by 5 and over to the right by 2. Here's the last page. Take a look at the correct answers. Make sure they make sense to you. If needs be, pause the video so you can take a look at them. Now the last page. Here we go. Again, if I'm going too fast for you, pause the video. You got plenty of time at home to take a look at this. All right. That's all I have for today. That was the review for the Unit 4 quiz. Good luck studying.